Good morning, students. Today I will be explaining you the experiment in which I'm going to find the refractive index of any liquid with the help of plane mirror and convex lens. In this experiment, the apparatus I'm going to use, first of all, I'll show you the apparatus. So look at the apparatus. I'll switch the camera. These are the apparatus which I'm going to use here. This is a pin which will act as an object. This is a stand in which I have fixed the pin. Then this is convex lens which I'm going to use, and one plane mirror and 1 meter scale. That's all. And the liquid जिसका हमें refractive index find out करना है. The most easily available liquid is the water. So I'm going to use here water. How we will calculate the refractive index, or how we are going to measure the refractive index? Look at here. And the arrangement will be here. This is the manual which I have taken. This one is comprehensive practical physics for class 12. This is for the CBSE I am using. So how I am going to use the apparatus? There is a plane mirror where I will put some water, and this is the lens, convex lens. You can see in the picture that the liquid lens, that is water lens, the shape of the water lens is plano-concave lens. So we'll find the refractive index by using the lens maker formula. The formula we are going to use to find the refractive index is n is equal to 1 plus r upon f2. So I will explain what is f1, what is f2, and what is r. R is the radius of curvature of this liquid lens or the convex lens. N is the refractive index of water which we are going to find. F1, F2 and F. There are three F here, capital F, F1 and F2. Capital F is the focal length of the combination of lenses. ये जो this one, the convex lens and the water lens, ये जो combination है, that is focal length of the combination of lenses. F1 is the focal length of the convex lens, and F2 is the focal length of the liquid lens. And we know that 1 by F is equal to 1 by F1 plus 1 by F2. So from this formula we can find the value of F2. 1 by F2 will become 1 by F minus 1 by F1. So we will measure F and F1 with the experiment. We will calculate F2, and by substituting the value of F2 and R, we'll find the value of refractive index N. R is the radius of curvature of the lens, convex lens, this one, which I am going to measure with the help of spherometer. That also I am going to show you. So first we'll measure F and F1. How we are going to do this? So let's do it. Look at here. I have arranged the apparatus. I have kept the object pin here. Then I have taken one plane mirror and one convex lens. First I'll keep the lens on the plane mirror and we'll see the image of this pin, especially the image of the tip of the pin in this convex lens. You can also see here the image is there. Then we will remove the parallax. By removing the parallax, what we mean? We mean that the position of the object and image of this object should be at the same place, like here. There should not be any relative displacement. Means if the object is here, the image will be just above the pin. So I am checking. I have set and I have removed the parallax. That means if I am moving the camera, if I am moving the phone, then both the object and image should go together. Can you see it here? Both object and image are moving together. So this distance we will measure. There is a gap. A gap I can fill by moving this plane mirror towards the object. Yes, now it's almost done. So the image and the pin both are moving together. So this distance we will measure with the help of this meter scale. Once we will measure from the plane mirror and then from the lens. So plane mirror, from the plane mirror, the length of this is, you can see it clearly, 21 centimeter from the plane mirror, and from the lens again I am going to measure the distance. It is from the center of the lens, it is 20.5. It is 20.5, and this one is 21.5. So from the plane mirror the distance is 21.5, and from the lens it is 20.5 without liquid. Now you take the observations without liquid. From lens surface it is 20.5, from plane mirror it is 21.5. so if we take the average, it will become 21. So f1 will be 21. Now even we have to find the rough focal length of the convex lens. I'm going to measure this with the help of my friend. So I'll take it later. Now with liquid, what we will do now? We will put some water on the plane mirror and will keep the lens so that liquid lens will be formed, and again we will remove the parallax such that the pin and the image, suppose the position of the image is here, then there won't be the removal of the parallax. But if the position is just in the same plane, then we say that the parallax has been removed. So after putting the water, I'm going to show you the same thing. Wait a minute. I'm putting the water on the plane mirror. Just pour little amount of water, बहुत ज़्यादा नहीं डालना है, such that it covers whole surface of this lens. Now I have kept it, just I am adjusting this so that there is water on the lens surface. I have to remove it. Now I have kept the water between lens and mirror. Now again I will remove the parallax. Now you see this time parallax is not removed. Can we see the image of this pin? It's too magnified. We are not able to see the image. So we'll move the pin bit far from the lens. Now I can show you, this is the image formed in the lens, and both the object and image both are moving together. There is no parallax between the image and the object. So this has been done by bringing the pin away from the lens. Remember one thing. If you see that if the pin is moving faster than the image, then you will move the pin towards the lens. And if the image is moving faster than the object pin, then you will move the pin away from the lens. Remember this point. Now I will note down the length of this. Now I am taking the length of this object pin from the lens surface and from the plane mirror. From the lens surface it is coming out from lens surface it is 30.8 29.8. If I can show you clearly, 29.8, and from here it is 30.8. It is 30.8. So I am noting down this. So from lens surface x1 with liquid you will write 29.8. From plane mirror you will write 30.8. If I will take the average, it will come out to be 30.3. So I am writing here 30.3. It will become 30.3. By substituting the value of f1 and f, we will calculate 1 by f2. Remember this, we have to take the sign of capital F and f1 both negative. So it will become minus 30.3 plus 1 by minus will become plus 1 by 21. After calculation, we'll get the value of 1 by f2, and we'll substitute here value of f2, and by dividing r by f2 we'll find r by f2, and then by adding 1 we will get value of refractive index of water. As you know, I have taken the liquid water, and the refractive index of water is 1.33 approximately. So 1 is already there. The value of r by f2 should be equal to 33. The radius of curvature, as I said, the radius of curvature of this lens is 21 centimeter, which I have calculated with the help of spherometer. In separate video I will show you how to calculate the radius of curvature of the convex lens, or if possible I will try to add in this video only. So radius of curvature of this lens is 21 centimeter. Now I have got, let me calculate the value. Now I have calculated here by substituting the value of f1, I have got the value of f2. मैंने पीछे रफ में किया है. f2 की वैल्यू आ गई हमारी 66.66. If by substituting the value of radius of curvature, that is equal to 21 centimeter, r by f2 comes out to be 0.315. So finally the refractive index of water is 1.31. 1 plus 0.31, that is 1.31. As I said, as you know that refractive index of water is 1.33, so it's quite closer. Again I'm going to explain this in 2 minutes, the whole experiment. What I'm going to do, first सबसे पहले हमने इस मिरर को रखा, पानी नहीं था, पानी हटा दिया, and हमने पैरलेक्स रिमूव किया. We remove the parallax by increasing or decreasing the distance between the lens and the pin. Parallax remove किया, then we note down the distance from the lens surface, from the plane mirror, and that was without liquid, and then we took the average, and that is the value of f1. Now I kept some water on the plane mirror, then I kept this lens, and again we remove the parallax between the object pin and the this lens. I'll show you what do I mean by removing the parallax. If I can show you, this time I have changed the position. So yes, this one, both the object and image both should move together like this. Again we note down the position from the lens surface and from plane mirror with the help of this meter scale. We have noted it down. We took this 2 value will be negative on the same side of the object we are measuring. So by substituting the value of f and f1, f is the focal length of the combination of lens, f1 is the focal length of the convex lens, f2 is the focal length of the liquid lens. So by doing this, by calculating, I get the value of f2, and substituting the value of f2 and r, we got the value of refractive index of water. One thing you would like to know, the radius of curvature, I will try to add in this video. So till then, okay, bye.